My name is Darlington Okoka, and I welcome you to Delwit Electrical YouTube channel. In this episode, we shall be discussing on resistance in series and parallel in an electrical circuit. But for this particular section, episode 1, we will focus basically on resistors in series, and in the second episode, we shall focus entirely on resistors in parallel and a joint circuit of both series and parallel. Now, before we venture into design and calculations of circuits in series and parallel, we need to extensively explain the fundamental law that deals with resistance, voltages, and currents, which is the Ohms Law. Ohms Law states that the voltage V across a conductor is directly proportional to the current flowing through the conductor I, considering the fact that temperature and other physical elements remains constant. That means from the formula, we have V is directly proportional to I. Then V, putting the equality sign, is equal to IR, where R is a constant signifying resistance. So our resistance is measured in ohms, the voltage is measured in volts, V, and the current is measured I in amps. So considering the fact that in every circuit, you might not see a circuit that is just going straight. So there is need to combine various resistors in a circuit. So that's why we have resistors in series and resistors in parallel. So let's see how we can combine elements within a circuit. Now, resistance in series. Resistance are said to be connected in series when same current flows through all elements within the circuit. That means from our circuit here, the current flowing from the voltage source here goes through R1, goes through R2, goes through R3, and comes back to this. So it's the same current that flows through. So this circuit is said to be connected in series. Now, from our calculation of Ohm's law, we got a formula in our equation 1 in which we said V is equal to IR. That's equation 1, standard Ohm's law, where V is the voltage, I is the current, then R resistance. Now, from this circuit, as you can see, this is our source voltage. The voltage across R1 is V1. Voltage across R2 is V2. Voltage across R3 is V3. So the total voltage VT, which is our V, is the sum total of V1, V2, and V3. And that serves as our equation 2. Then, if you look at it properly, our V1, this V1 you see here, the current coming here, we say it's same current because it's in series. We are going to prove and see how you see that the current coming here, when you get to R1, let's call it, since it's the same current that flows, so our I will be here. So let's say the current here is I now. So we have our I here. So the I coming here is the same I that is in R1, the same I that is in R2, the same I that is in R3. So now for our V1 is now equivalent to I R1. Our V2 is I R2. Our V3 is I R3. That is going to give us our equation 3. Now, if we substitute equation 1 and 3 into equation 2, we will have our equation 2 is V. From Ohm's law, we have V is equal to IR, which is this. IR is equal to, our V1 is IR1. Our V2 is IR2. Our V3 is IR3. So we have IR is equal to IR1, IR2 plus IR2 plus IR3. Then IR now, since the I's are similar to all of them, we'll put them in brackets. So our IR will be equal to I in bracket R1 plus R2 plus R3. So if we divide both sides by I, we have R is equal to R1 plus R2 plus R3. That means for equivalent resistance in a series circuit, we have R equivalent is equal to R1 plus R2 plus R3 plus to infinity Rn. So the summation of all R's in a circuit, in a series connected circuit, will give you your equivalent circuit. So in summary, for series circuits, we have 4 fundamental sum we are going to take home for a series circuit. The first one is that for all series circuits, the same current flows in all parts of the circuit. So from R1 to R infinity, we have the same current flowing through it. Secondly, the voltage drop across each resistor within the circuit is different because their resistance value is also different. So for our R1 now, our V1 is different from V2, our V2 is different from V3. So you can now see that for series connected circuits, current is constant, but voltage changes according to the resistance value of each of the resistors. Number 3 take-home point is that the sum of the voltage drop is equal to the voltage applied across the circuit. So from this circuit now, you can see that V1 plus V2 plus V3 to Vn must be equivalent to V, which is the source voltage. Then finally, the voltage drop, the resistance, and power are all additive. So what am I trying to say is that your V, your R, and the power P, which we are going to talk about later, they are all additive. So for that, the summary we are going to take from a series circuit. So I'm going to show you a graph. This graph shows that there is a progressive fall in potential difference as we go from point A to point D. Do you understand? So as we go from the circuit diagram, as we go from point A to point B, there's a voltage drop. As we go from point B to point C, there's a voltage drop. As we go from point C to point D, there's a voltage drop. That means if you connect a circuit in series, the voltage in R1 will be high. When you go to R2, the voltage will drop. When you go to R3, the voltage will drop. So we're going to carry out a practical section whereby we'll connect 3 lamps exactly as it is in the circuit. We'll connect it, our lamp 1 will be R1, lamp 2 will be R2, our lamp 3 will be R3. Then we'll connect a voltage source to 220 volts and see how the illumination will look like. You will discover that the voltage at R1 will be far higher than the voltage on R3. So we'll go into the practical section. You're welcome to the series connection practical section. Now from the circuit diagram that is displayed, we saw that from this source, we'll go to R1, R2, R3, and back to the source to form a complete circuit. So in this practical section, we're going to be using the 100 watt bulb equivalent. They are all 100 watts. Connect them to their various locations and see if the illumination will be different. So for series circuits, the same voltage that is here that is different from the voltage that is there, is different from the voltage that is there, but the same current flows across. So let's see how this connection is done. We have our live wire. This is the live wire that we're going to be using. So, and this is the stripper. Now you can see that the connection has been done. If you look at it properly, the series connection, you will see that this is the live. The live is coming here, the neutral is at the extreme. So from the live, you go to the neutral comes to the live. From the live again, from the neutral, it goes to the live of this. Then from the live of this, the neutral of this comes back to the source. That forms a complete circuit, the circuit that I've shown you initially. So this is a perfect example of how your series circuit is being connected. So now, what we're going to do now, we're going to see if the voltage drop actually works. Now you can see that the live is coming from here and the neutral is coming from the last side. So these are the bulbs. Let's insert the bulbs. So we've connected it. Now we want to see if there will be any voltage drop across the line. So let's put it on. Can you see that this has a full illumination? This one has a smaller illumination, and this one is low. The two, there's a decrease. There's a perfect decrease in voltage. That means these are R1, these are R2, and these are R3. This has a higher voltage than this. But how which the entire one has, like in parallel circuit, we're still going to do a connection in parallel. When we do a connection in parallel, you discover that the voltage here is equal to the voltage here and is equal to the voltage here, and they will all illuminate at 220. So this is 220 volts. By the time you measure this, you discover the voltage here is higher than the voltage here, is higher than the voltage here. So I believe you've been able to understand how the series connection works, and this is exactly the practical aspect. So all the calculations you are going to be doing in that series is all the same principle. I believe that this series calculation, resistors and series calculation, has been very educative. If you have any question, any comment, please kindly state it in the comment section, and be rest assured that I will attend to any question you ask in the comment section. If this video has been educative to you, kindly click the subscription icon at the top of the screen, and also click on the notification icon to get notified when the subsequent videos will be released. We are going to be talking about the parallel connection after this video. So please stay tuned and click the notification icon so that you'll be alerted when we post that video. Thank you for watching Delwit Electrical YouTube channel.